back to another video. Believe it or not, it has been exactly 1 month since I last went live. If you can see it here. Oh wait. Was I audible? One moment. Flip. Alright, I don't think I was audible. So basically what I was saying is it has been 1 month since I last recorded a video, believe it or not. And alright, something happened to I fuck. Oh well. You know what? Screw this. I'll figure it out later. So basically it has been 1 month since I last went live, and this live stream I hope to simply just revise whatever it is that I've been revising and just make some progress. Okay, revise arrays and then revise hashing, and this includes revising the library of default dict in Python, and then revise strings, this 5 problem, and then hopefully make some progress. That's pretty much it, man. It's gonna be a silent kind of a live stream. Nothing much. Nothing much. Nothing much. Not bad. Okay, the quality is not bad, but the problem is in the full display I don't have the audio capture, so when I switch to the full display you guys will not be able to hear it. Alright. Oh, you guys can. Wonderful. Wonderful. Alright. Yes. So we'll be... Thanks to DRM, you guys wouldn't be able to see this video. And... that's it, man. Recap, right? Just recap everything quickly. And then... make some progress. Let me get myself a clock and I believe doing the arrays, recapping everything, and then recapping the default dict would not take me more than 30 minutes, or even if it does take more than 30 minutes, even if it will take me more than 30 minutes, I plan to squeeze it under 30 minutes. So arrays and then hashing, and then the 3 problems of hashing, and then quickly revise default dict. Default dict involves recapping 7 problems. Alright, let's get going.
How do I do it? We know one thing. If we are given, so I'll write the function. I'll not be writing the entire code. It's not required. It is not required. I've been repeatedly stating you don't have to write this. You just so can I initially have a sum variable as 0? I can. What do I need to do? If the array has 5, maybe in that sum variable I could add a 5. Then I can go to 6, I could add that 6. Then I can go to 10, I can add that 10. Then I could go to 4, then I can add that 4. So I need to go to each and every element. I need to go to each and every element. How do I do that? I can do that by simply traversing the array. By simply traversing the array. That is what I will do. I'll be like, how do I traverse? I traverse from I equal to 0 till the last index, because when I say all the array elements, it means till n minus 1. All I need to do is sum plus array of I. So what will happen is first array of 0, then once in your specific language, odd numbers. You have to pick it up. You'll be able to. The reversal will always be 1 to 1 itself, right? So you can guess it and you can get the correct answer as well. Look at the function signature. For CPP, you have a void. Similarly, for Java also, you'll have a void. And for Python, JavaScript also, you'll have a void. What does a void function means? You don't have to return anything. You do not have to return anything, which means because the array is passed by reference, remember the lectures, the basic lectures. Because the array is passed by reference, you'll have to modify the array within itself. You'll have to modify the array within itself. Let's understand. So if I go to the iPad, I have an array 1, 2, 3, 4, 5. What I need to do is I'll be given this array. I'll have to make, but within to find a 10, just the thought, the array of the same size. To do a reverse traversal. Why? Because this is a temporary array of size 5. Now this typically would have 5 places. 5 places, you need to understand. This temporary has 5 places, but it doesn't have any element. It doesn't have any elements. All of them will be garbage values. All of them will be garbage values. So what I need to do is I need to take this 5, put it here. I need to take this 4, put it here. I need to take this 3, put it here. I need to take this 2, put it here. Take this 1 and put it here. I need to do this at my first step. Okay. How can I do this? And it's very simple. All you need to do is you need to run a loop from I equal to 0 and you have to go till n minus 1. So can I say, because you're accessing array of I, which is this one, the first element is this array of 0. The first element that you're accessing is array of 0. Where does array of 0 go? Where does array of 0 go? Can I say that the array of 0 will always go to array of 4? I can say that. And can I say that the array of 1 will always go to array of 3? I can say that as well. Can I say that the array of 3 will always go to array of 1? That is what will happen. So initially, try to take them into temporary. This is nothing but n minus 1 minus I, isn't it? Yes. Simple pattern printing. This is on the same stature. Can I say then temporary of n minus I minus 1 will be array of I? So that what will happen is when I is 0, this 1 goes here. When I is 1, this 2 goes here. When I is 2, this 3 goes here. When I is 3, this 4 goes here. My temporary lines of add the temporary into array. The reverse. So I've made sure that my temporary has the array reversed. I've made sure that my temporary has the array reversed. I can simply do it by writing these lines of code. Once this is done, all I need to do is I need to put back the temporary into array because I need to reverse the given array. I need to reverse the given array. So what I'll do is I'll simply run a loop again from I equal to 0 till n minus 1. I'll be like, hey, array of I, can you replace yourself with temporaries I? That's it. So what will happen is this 5 will go here. So it goes, maybe I can use some other color. Yeah, this 5 goes here. So this is 5. This 4 will go here. So this is 4. This will be 3. This will be 2. This will be 1. That's it. So I stored a temp and then I put it back. Then I put it back. This is what you could do. And if I have to write the pseudocode, like the clean pseudocode, it will be, void, reverse. All you need to do of n minus I minus 1 is equal to temporary of I, because you do not need to return anything. Is the time big of n into 2 and analyze the time complexity. I can say that I'm running a big O of n here, and I'm again running a big O of n here. So it's a big of n into 2. And what about the space complexity? I'm using a temporary array which is of size n to store it. That's why this is not a preferred way of doing it. You might ask, hey, why did we require temporary of n? Because you need to understand the array was 1, 2, 3, 4, 5. So if you traverse to this one, which is the 0th index, and you say that, hey, this one should be here. So basically what you're doing is just putting it there. You're just putting it there, right? So the 5 will be gone. The 5 will be gone. There's no way that you're storing this 5. There is no way that you're storing this 5. So there will be an issue. That's why you need to preserve all the numbers in a reverse fashion, right? Okay. So can I do better? Can I actually remove this thing? Yes, I can. Yes, I can. How? Let me explain. So you have 1, 2, 3, 4, 5 in the array data structure. What did we do when we were reversing? All we did was we took the 1 and we did put the 1 over here, right? And we took this 5 and we did put this 5 over here. If I'm able to do this, I think my job will be done. 5 goes here and the 1 goes here. Perfect. And at the next step, I need to take this 2, put it here, and you take this 4, put it here. So this will become 4, this will become 2, and you're done. If you see the array is reversed, you don't need to do for the middle element. You don't need to do for the middle element. If you say it is 5, 4, 3, 2, 1, the array is reversed. So if I go back some steps, how did I do it? All I did was I said for this one, when I'm traversing, this is nothing but the I equal to 0th index, whereas this is n minus I minus 1th index, correct? So I can keep reversing, but I'll have to make sure, that we just reverse till here, because we can't keep on reversing till the last element. Because if I go here and if I again swap, the swaps will again happen. So I just need to swap these two elements. Like I just need to reverse, like swap these first two elements, only the first half. Because if I'm reversing the first, like if I'm changing values of the first half, my reversal will be done. So the best way to do this is you use a approach known as a two-pointer approach. You use an approach known as a two-pointer approach, where you say that, hey, listen, I have a left pointer which is pointing at 0. I have a right pointer which is pointing at the last index, which is 4 or which is n minus 1. And all I need to do is I need to swap these two elements. Swap. How can you swap? For this, you will be using the 3-variable concept. So we know that one of the elements is array of left, while the other element is array of right. So I need to make sure I swap them. The first thing you'll do is you'll take a temporary variable and you'll store the array of left. So I've stored the array of left. And what is array of left? That is 1. So the temporary as of now has 1. Right after that, you will say array of left, can you store array of right? So what will happen for this particular statement is the 1 will be changed to 5, because array of right is 5. Now the thing is, in array of right, I need this one, but I've already replaced it. This is why I required a temporary variable which stores it from where we can pick it up. So all I need to do is I need to write equal to temporary and take this pointer. I could take this pointer and I can move it one step up. Yes, I could move it one step. Shrink this. This will be, it goes here. Again, it will be here and the right will be here as well. So whenever the left and right collide or the crossover, we stop then and there. Whenever the left and right collide, or we stop then and there. Got it? So if I have to write down the pseudocode, how will it look like? Very simple. Element. So there is an internal swap function you can use, or you can equal to 0, right, equal to n minus 1, because that is where the last element is. I can say that till they collide, till left is smaller than right, because if they've crossed over, there's no need to do it. So there is an internal swap function you can use, or you can use these 3 lines as well. I'll leave it to you. So just write swap of array of left, comma array of right. So this will make sure that you have swapped it. After that, all you need to do is, move left to one place up, which is left plus 1, move right to one step back, which is right plus 1, or you could also write, instead of this, you could also write right minus minus. It means the same. When you write right minus minus, it means right minus 1. Perfect. Right after this, you could close it because it is a void function. You do not have to return anything. You don't need to return anything. So this is how we can easily do the reverse and array stuff. So the next problem that we will be solving is check if the array is sorted or not. So given an array of size n, the task is to is to check if the given array is sorted in an ascending order. In an ascending order, very important. If the array is sorted, then you'll have to return a true. Otherwise, you'll have to return a false. So this is how the function signature looks like. You're given the array, you're given the n, you need to return a Boolean value. Okay. So 1, 2, 3, 4, 5, that is sorted, so it will be true. This is definitely not sorted, so false. Let's check it out. Is this sorted? Yes, but in decreasing order. I need it in an increasing order, so you could give a false, and that is it. Awesome, 10 points. Perfect. How do I solve this particular problem? Isn't it easy? Like, we have the array as 1, 2, 3, 4, 5. How do I check if it is sorted or not? We know one thing for sure. If I'm standing here, all the elements on the right should be greater, correct? If I'm standing here, all the elements on the right should be greater. If I'm standing here, all the elements on the right should be greater. If I'm standing here, all the elements on the right should be greater. If I'm standing here, all the elements on the right should be greater. So because we are checking for ascending order, a greater than equal to, yes. That's all I need to do. So what is this? The 0th index. So when I'm standing at the 0th index, I need to check for, let's call it as I. I need to check for I plus 1 till n minus 1 if all the elements are greater or not. If either of them are not, there is a problem. If this was 0, there is a serious problem. It is not sorted. Similarly, if I is over here, I just need to check for I plus 1 till n minus 1. These elements, all of them should be greater. It's easy, right? So the naive solution, would be very, very simple. All I need to do is, I need to write void array sorted or not. So I'll just call it as function. You're given the array, you're given the n. So I'll be like, for every element, I equal to 0 till n minus 1. Because this will make sure I'm going through each and every element array of I. I need to check for every element. I need to check for a j I plus 1 till n minus 1. That's how we did in patterns. We need to check for every element, right? And what I'll write is, hey, listen, if I element array of I need to check for every element. I need to check for a j I plus 1 till n minus 1. That's how we how we did in patterns. We need to check for every element, right? And what I'll write is, hey, listen, if at any moment array of j comes down to be lesser than array of I, that means there's a problem. And there's a problem. And if there is a problem, you could straight away return a false. And that is it. This for will end over. And right at the end, you could return a true. So how this works is, this is very simple. This function is called, then you pick up array of I, then you check from I plus 1 till n minus 1 for each and every element. If at any moment you get something which is not possible, you return a false. So you break the function. If you're writing return at any stage, the function stops then and there. It returns. The function stops then and there, and it returns. But if this function never got executed, the for loop will be over and it will reach here. So a true will be returned, stating all of the things were true. So what is the time complexity? You know what is the time complexity? Near about big of n square. Not exact n square, not exactly n square. And you know the reason. I've already taught it in the time complexity lecture. Go back and watch it. So it is a big O of n square. What is the space complexity? A big O of 1. Obviously, this is something which can be optimized. And I'll be checking out the optimal solution. Okay, so how do I optimize this? Don't you think? Like, don't you think one thing? If I'm standing here and there is a 1, and if this 2 is greater than 1, then I could just check if the 3 is greater than 2, and then I could just check if the 4 is greater than 3. That's the only check I need to do instead of, for one, instead of checking for all elements. Can I do a single check? I think I can. If I start from 2, I need to check if 2 is, greater than equal to 1. That's only the check that I need to do. If I write it, can I write it something like this? 2 greater than, can I write it like this? Then only I call it.
Oh goddamn! Wasn't it already the solution that I implemented? Sheesh. It was. Why did I change it though? Okay, but the problem is there is going to be an out of index error.
Then only I call it ascending. Yes, I'll do the same thing programmatically as well. I need to start the check from here, which is I equal to 1. Very important pattern to observe. I start from I equal to 1. So all I need to do is, okay, void function. It's not a void function. It's a Boolean function. My bad. It's a Boolean function, not a void function. Boolean function. Array comma n. So we are having a Boolean function. Right? We are having a Boolean function. I can say, hey, for I can start from 1 and n minus 1. All I need to check is if array of I, if that is at any point less than the array of I minus 1, because if this is I minus 1, isn't it? The previous element will always be I minus 1. The indexing are continuous rather. If this is the case, can I say this is a problem and I could return a false? Otherwise, I could return a true and we are done. Over here, all I did was run a single loop. So the time complexity now is a big O of n. And just
Beautiful.
and the space complexity is a big
Alright, I keep forgetting to perform the time and space complexity.
go of 1. Simple as that. also stored in a memory block. But base problem. CPP, you have a void. Similarly for Java also you have a void. Again, of code. One will go here. Maybe anything. Let me explain. So you have 1, 2, 3, 4, 5 in the array data structure. What will happen is the first half, my reversals will be done. All I need to do is store array of right. So what?
Booyah. One is completed, bruv. I do a different approach. This one's very intuitive. Beautiful. What's really happening? Time limit is exceeded. Wow. Alright, I'm not decrementing or incrementing. That works. Submit. View analysis. Hopefully it will be O of n by 2, which is O of n. Yes. Alright, I'm gonna be stopping the live stream right here because I just wanted to do a live because it has been quite a while since I did, exactly 1 month, and I did not want to postpone it any longer because the whole point was to build accountability, right? And I will be coding after the live as well. So what did we do? We completed a race. That's pretty much it. 30 minutes, not bad, right? I've been on live for 36 minutes and we did a couple of 2 problems exactly. Not satisfied with the pace or the speed, but hey, a live stream is a live stream. I will take it at that. So what I'm going to do tonight is complete this recap 7 problems that I have here. All of this. These are some problems that I did earlier to learn default dict library of Python, and after that I'm going to do all of this 3 and then all of this. That is my goal, and before I hit the sack, that would be my goal, and that's pretty much it. So hopefully by tomorrow I'll do this 3, and by this weekend we'd be able to do all of this. And if I do that, that's 1 2 3 4 5 6 7 8 9 10 11 12 I've got a OA online assessment. I've got an online assessment of a company coming around at 31st. So yeah, 30th will be spent primarily in revising core subjects, which is operating systems, computer networks, DBMS, and yeah, hopefully by this weekend, hopefully by August 3rd, I complete this. So from August 4th, we would enter by August 4th we would enter this. That's it. Alright. See you later. Alligator. That's it, my guy. Hopefully I get a job, man. Hopefully I get a job. I still have not posted my first YouTube video, as in a non-live stream video. But I will be eventually. Hopefully after I get a job, because I don't want to waste time scripting and recording and do all of that at this phase. Alright. Have a blast. See you next time.